Good morning, students. Today we'll discuss the notations used in designing the transaction diagram in the finite automata. Okay, so startingly, every state is represented with a circle, and the inside the name is a state name. Okay, it can be Q0, Q1, Q2, S, A, B. So depends upon the question, there will be a state. Okay, and arrow indicates the starting state, and there will be no more transaction coming from this arrow. Starting arrow starts from an arrow is called a starting state, and double circle is represented by a final state, and your arrow between the two states, we say it as a transition taken from Q0 to the Q1 with the input symbol 1. Okay, and this is called looping. Whenever the transaction has to taken place to the same state, we say it as a looping. We'll consider like this one. Okay, this is a normal representation of the transaction diagram in the DFA or in the finite automata. There are three types of finite automata. One is DFA, second one is NFA, non-deterministic finite automata, and non-deterministic finite automata with epsilon most. These are the three types of finite automata. Now we'll see the definition of a DFA. So D means deterministic, F means finite, and A means automata. Here automata is a machine which accepts a string or rejects a string. Okay, and finite means countable number of states or edges it will contain. And deterministic means there will be exactly one transaction for every input symbol from the state. And consider the input symbol 0, 1 means every state should take the transaction for both the input symbol 0 as well as 1. Okay, next one, DFA is a 5 tuple representation, or quadruple we call it as, or 5 component representation. So it is said to be M is equals to Q, sigma, delta, Q naught and F. Okay, M is a finite machine, or the name of the machine we can call by any name. So normally we'll represent by M. And Q is a non-empty set of state. Q is a non-empty set of states, like we can represent as Q0, Q1, Q2, so on. And sigma is a non-empty set of input symbol. Normally we'll use 0, 1, A, B, C, small a, b, c like that as a input symbol. And delta is a transaction function which is mapping from one state to another state. Like transaction taken place from Q0 to Q1, it is represented like this. Q into sigma to Q. Okay, and Q0 is a start state which should be belongs to the set of states. Okay, Q is a set of state, no, it should belongs to the set of states. And F is a subset of Q. Means what? Subset means what? Minimum other set should be present as a F, which is called as a finite state, represented by a double circle, and start state should be represented with an arrow. So this is about the 5 components present in the DFA. Now we'll see the simple language accepted by a DFA. So L is the language, and it should accept 5. 5 means no empty language. 5 means it's an empty language. So empty means minimum one state should be present with the starting arrow. Okay, next one, with the empty, we should accept an empty language means epsilon. Epsilon means there is no language present, empty string. So empty string means it should be accepted. Always every string should be start from the starting state and end at the final state. So starting state is represented with an arrow, and double circle is said to be a accepting state. So here final state or accepting state. So here both starting state and accepting state, we call it as a empty string. Okay, there is no string given to this machine. Okay, next one, exactly, DFA to accept exactly 1A means only 1A it should read, not more than 1A, not less than 1A. So that time how to write this one? So here starting state you have to write with an arrow and the single circle, and the transaction taken place with the A as the input, and the accepting state or the final state represented by a double circle. This is how you have to write the transaction diagram for accepting exactly 1A. Okay, and next one for AB. See, for one transaction there should be only one input. Whenever there is more than one input value, then you have to take one more state and you have to mention the transaction. So your starting state with the one state and again one input symbol, again one more state, one more transaction, one more state. Okay, so here they are given only AB. So after AB it should be accepted. So we are making it as a final state. Next one. DFA to accept a string consisting of any number of A's denoted. So any number of A's. So consider A star means it can be epsilon, single A, double A, triple A or any number of A. Whereas A plus means it will be A. Minimum one A should be present. A plus means minimum one A should be present, followed by it can be any number of A's. So in this transition diagram you can see it will contain, it is a star means it may directly can be final state or any number of times it can read the A's. Okay, so this is a machine to accept any number of A's. If there are more than one input symbol, so that time it is represented like this: A plus B star. Here A plus B star means it can accept any language. Like consider it can accept A. One time if it reads, it may accept A, it may accept B, it may accept epsilon. Without reading also it is called a, it can reach to the final symbol. Otherwise AB, BA, BAA, ABA or any occurrence or any sequence of ABs it can read. Okay, so this is called any number of A's and B's. There is no condition that A should be followed by B, B should be followed by A, like that. So this is a simple representation of any recurrence of A's and B's. Now we will see the proper example problem of DFA. So DFA to accept a string consisting of at least one A. So at least one A means we can say it as A plus. Okay, A plus means minimum one occurrence of A should be there in the design. So what we have to, how we have to design? So firstly, minimum one A should be present. So we have to take a transaction from the start state to the accepting state, and then it may contain any occurrence of A. So here minimum one occurrence of A it will read, then only it will reach to the final state. Then it may read any number of A's. So here we call it as at least one A is read by this machine. Okay, now whenever you are writing a machine, you have to define the DFA with the 5 tuple representation or 5 component representation. So M is a machine name, so you can give any of it. Then Q is a number of states or a set of states present in the design diagram. So here states are Q0 and Q1, and delta is a transaction taken place. So delta is shown in the table, transaction table we call it as. So del is a transaction from state for the given input A. So here states are Q0 and Q1, whereas Q1 is a starting state represented by arrow and Q1 is a final state. In the transition table it is represented by a star. Okay, in transition diagram represented by double circle, whereas in the transition table it is represented by a star. Now for the Q0, from the Q0 starting state for the input A, Q0 from the starting state for the input A, it is reaching Q0 to Q1. So here you have to write Q1. Similarly, Q1 for the input A, it is reaching to itself. Q1 to the input A, it is reaching to itself. So you have to write Q1 here. So like this, for every transition diagram, you have to write the definition as well as the transition table. Now after this, now we have done next Q0. So Q0 is the starting state, and next one F, final state or accepting state, that is a Q1. So this is how you have to write the DFA for every problem.